My name is Angelique Demetillo, and I am a PhD candidate at the University of Virginia in the Department of Environmental Sciences. I work with a wide array of high-resolution nitrogen dioxide data as measured from satellites, airplanes, and ground-based instruments in order to observe air pollution inequality within cities.
And I'm Dallas Tatman, a PhD candidate in the Department of Religious Studies. My main area of concentration is the history of African religions. Over the past 3 years, I've spent a total of about 16 months in Senegal, studying language, culture, meeting people, primarily in the capital city of Dakar.
Bonjour Dallas, ça va? Nanga def?
Bonjour, Angelique. Gaya gnalagis. Mangi firak. Nakaligebi.
Mungsi jam, merci.
Wow. Sunuhisa tambalena si Université de Virginie.
Allons-y.
Sikau? Sikanam. Angelique and I traveled to Dakar to investigate ground-based air pollution in Senegal. Located on the Cap Vert Peninsula on the west coast of Africa, Dakar, Senegal is a rapidly growing metropolis with a population of about 2.5 million inhabitants in an area smaller than Richmond, Virginia. First settled by indigenous Lebu fishermen in the 15th century, Dakar was the official seat of French colonial power in Africa from 1902 to 1960. During this time, Dakar was a template of urban planning throughout West Africa. Today, this westernmost point on the African continent still serves as the industrial, economic, and intellectual hub for much of West Africa. Unfortunately, studies of air pollution in African cities have centered around measuring particulates, or utilizing air-to-ground satellite data, or even modeling structures based on patterns observed in North American and European cities. When Angelique and I first collaborated, we sought to observe air pollution levels in Dakar by addressing two types of data-driven questions. Firstly, how do ground-level observations of air pollution compare to space-based measurements? And secondly, how can we tell the story of the data in a way that reflects the experiences of the inhabitants of Dakar? Thanks to funding from the Data Science Institute at the University of Virginia, we had the resources and the opportunity to approach this problem.
Earlier this year, Dallas and I collaborated with students at the Université Cheikh Anta Diop in Dakar, or the University at Dakar, and together we measured NO2 throughout the city. To do this, we equipped a local vehicle with a Teledyne 500U CAPS NO2 analyzer and conducted 6 to 7 hours of sampling per day for 3 weeks. Altogether, we've sampled nitrogen dioxide from February to March, representing the dry season in Dakar, the season in which air pollution is expected to be its highest. We drove throughout the entire peninsula several times, collecting sufficient repeated measurements with enough spatial coverage to statistically sample the entire city at 300 meters by 300 meters resolution, which is much finer resolution than current space-based observations. Early results show that modeled NO2 mixing ratios predicted without local NO2 measurements are not only significantly lower than measured, but are also incorrectly distributed throughout the entire city, especially compared to observations.
Thank you to the UVA Data Science Institute for allowing Angelique and I to collaborate. A very special shout out to our mentor, Professor Sally Poussette, who provided invaluable guidance and resources throughout this entire process. Additionally, we'd like to thank Professor Drame, Aissatou Faye, and Demba Nyang from Université Cheikh Anta Diop in Dakar. Without them, this project would not have been possible at all. Looking forward, Angelique and I hope this project will encourage further collaboration between scholars from different disciplines like the sciences and the humanities. So as we say in Wolof, when we're taking leave of someone, ba banain yon, or until another time.